Okay.
Mm-hmm.
All right. This is Margaret Booker. I'm the co-lead for the Southern Blue Ridge Fire Learning Network, and I'm excited to have Cassandra Pillai today present her master's project that resulted from her internship with the Wilderness Society in 2014 in one of our most fire-prone landscapes in the 8 landscapes in the Southern Blue Ridge. So with that, a few logistical things. If everybody could put themselves on mute. If you have clarifying questions during the presentation, please send a chat message. And otherwise, if you could hold your questions until Cassandra has finished her presentation, then we'll have another, 20 up to 30 minutes for questions that you can either call in after you press unmute or send a chat message. So with that, I would like to turn it over to Cassandra, and this webinar will be recorded, so you have a chance of listening to it again or pass it on to friends who may have missed the call. Thank you.
Hi, everyone. Thanks for tuning in and for listening. My name is Cassandra Pillai. I recently finished my Master's of Environmental Management at Duke, and this was my master's project that I, as Margaret mentioned, worked on as part of an internship for the Wilderness Society. So the title of the talk will be Wildfire Effects on Vegetation in Linville Gorge Wilderness Area. Just trying to, here we go. So just to kick everybody off in case someone's not familiar, Southern Appalachia is one of the world's most biodiverse temperate forests that has a long history of fire that extends back past Native American presence and then has increased in intensity with Native American presence up until the era of Forest Service fire suppression, which commenced in around the 1950s. However, in recent history, we've seen a resurgence of fire in Linville Gorge Wilderness Area starting back in the year 2000, and so that's what's prompted a lot of these studies. And there's concern that because of the long era of fire suppression, that our fire-dependent ecosystems and species are facing decline in habitat with increased dust layers, so litter on the ground, and many other things that accompany the lack of fire in an ecosystem. And so that has prompted Linville Gorge Wilderness Area to be a great study site to see the effects of repeat wildfires in a relatively untrammeled wild forest area. And so what I'll explain a little bit more about Linville Gorge Wilderness Area and then launch into more of the logistics of the study that we did. So Linville Gorge Wilderness Area is outlined in black on the map, and it is situated between Burke and McDowell counties in western North Carolina. It's got about 4,300 hectares of federally designated wilderness area, and tree core evidence supports a long history of fire, with some fires burning with high severity, and the severity is simply the amount of biomass that's burned with a fire. So there's a lot of biomass burned in the fire. And then some more frequent fires burning with low severity, but at unknown return intervals. So in the year 2000, we had a pretty large wildfire, and this was called the Brushy Ridge Wildfire. And what you're looking at now, what just popped up on the map, is a fire severity index called the difference in normalized burn ratio. And it's indicating high severity fires in red, or high severity areas in red, and low severity or unburned areas in green. And what you can notice, if you can see sort of the topography of the area, that the red is on the ridges and the green is within the sort of more mesic, more wet sites by the river. And that follows what has been documented in studies visually. There were several other fires between in the year 2007. So we had, again, similar patterns being followed. We had high severity areas burning along the ridges and lower severity areas burning along the slopes, and then unburned areas by the wetter sites. And then in 2013 was the Table Rock Fire, and again, similar pattern. And this fire is what prompted the Wilderness Society to request an intern for the assessment of established field sites, because we have this long history of fire, and it would be interesting to see what kind of changes we can document in the vegetation composition with these different fire events. So given the interest in analyzing the effects of fire over time, one of my primary objectives was to identify the structural and compositional trends in Linville Gorge Wilderness Area forests and to inspect those trends and overlay them with environmental variables. And my second objective was to determine whether these wildfires had been meeting any sort of restoration goals in Linville Gorge Wilderness Area. So as I mentioned, there's been concern that fire-dependent species are losing habitat and they're being replaced by fire-intolerant species. So I was looking for evidence of that either happening or not happening, as well as the encroachment of invasive species. So we'll get started first by talking through how I addressed the first objective and then move on to the second objective. And to kick that off, I will go through the historical work that's been done in Linville Gorge Wilderness Area. And I'm sure many of you are familiar, but just in case some people aren't. Back in 1992, a PhD student named Claire Newell established 181 permanent vegetation plots throughout Linville Gorge Wilderness Area. And in this map on the right, those plots are marked with the little blue dots. You can see those. And she distributed the plots strategically so that she could sample different vegetation community types and different geology types throughout Linville Gorge Wilderness Area. And she marked these plots with small pieces of silver tubing, and she left those in the ground at the sites. From her work, 7 different forest community types have been documented, and the 3 most common of those community types are xeric evergreen forest, which occupies xeric slopes and bluffs, and they have generally nutrient-poor soil. And typical species include Pinus pungens and Pinus rigida, among others. There's also Kelmia latifolia and Rhododendron maximum as being very common. She additionally identified acid cove and slope forests, and these are generally found in the narrow gorges, deep ravines, and low gentle ridges within coves, as Shafley and Weekly identified in 1990. And typically, there's limited species diversity, but you see a lot of Rhododendron maximum and Sugaria canadensis, among other woody species. And the other most common one, though not as common as xeric evergreen and acid cove forests, are montane oak forests. And these typically occupy the submesic to subxeric mountain slopes and peaks. They're relatively diverse. They have are dominated by Quercus species, especially Quercus montana or chestnut oak. Following the 2000 fires, there were 25 of the plots resampled in 2003, and this was done by Gary Kaufman and the United States Forest Service. And they resampled in only overstory species, which I'll explain more in a little while, but the understory species or below breast height were not collected. And then following the 2007 fires, we had 154 unique plots resampled, but a total of 172. Some of them were sampled more than once. But these were all of Claire Newell's original established plots. And then in 2013, my team resampled 21 of the plots, and that was all in the Table Rock area. Next, we'll talk through some of the data that was collected. And as I mentioned, all of this was done on the 1992 established plot, and they followed the University of North Carolina's Carolina Vegetation Survey methodology. And if you're not familiar, what this involves is setting up permanent plots by leaving a marker that typically are 50 meters long by 20 meters wide. And they have 10 by 10 meter submodules. So this is a submodule that you're looking at within a larger 50 by 20 meter plot. These plots have intensively sampled submodules, and that means that plants that weren't breast height or higher were sampled, so the understory vegetation was sampled. And it is sampled intensively in the corners at varying spatial scales. And this was done only for the 1992 and the studies between 2009 and 2011. The study in 2003 and my study did not do any of the low vegetation resampling. So what we did record was we recorded trees by their diameter at breast height, so how wide they are at 1.3 meters. And if the trees would fall below 40 centimeter diameter, they were recorded into one of 9 size classes. And if they were above 40 centimeters, they were specific DBH was recorded. We also recorded whether the individuals were live or dead at the time of sampling, and this was done not in the 1992 study, but in the studies following that. So this is not part of the Carolina Vegetation Survey. And if it becomes relevant for anyone at any point, we did collect visual estimates of fire severity, and I have those recorded. Those aren't incorporated into our study, but we have the data if it would be helpful for anybody. Next, I collected a bunch of geospatial environmental variables. Several of them I calculated with a digital elevation model, and I'll go through those in the next slide. And the source for this data was the U.S. Geological Survey, and the resolution for the DEM that I was using was 3 meters. You can see it pictured on the right. And then I also used geology and soil classifications that were from NRCS, and that had a 30-meter resolution. And then fire severity, which were the images that I showed in the very beginning, were calculated using the difference normalized burn ratio. And those were from Landsat 5 and Landsat 8 imagery and had a 30-meter resolution. So the included environmental variables, I tested many, but the ones that tested as having a significant correlation with the vegetation data were aspect, elevation, slope position, topographic convergence index, and the topographic position index. So I'll talk through just the last two because the others are pretty straightforward. The topographic convergence index is a quantification of the contributing upslope area to a specific place and is a way to model hydrology across the landscape. And then the topographic position index compares the elevation of an individual pixel in a raster to the mean elevation around that specific cell. So those both were useful in identifying trends in the vegetation data. And then additionally, I included geology and soil and the vegetation community classes that was intended to capture some variation or other covariates that weren't in the environmental variables that have been included in the analysis. So this is one of 7 of the vegetation classes. The fire severity variables that were included were all derived from the DNBR data sets, so difference normalized burn ratio data sets. And the severity that was measured by those, typically the mean severity was relatively low. It's an index that varies between negative 5,000 and about 1,300. And so the negative values are unburned, the positive values are very charred or very, very burned. And so you see that the relatively low severity above 0, but a large amount of variation in that data. So with that in mind, what I did was for the pixel with the plot that it included, I just simply extracted that data to the plot point. And so I did this for all of the different fires to capture the severity at that specific plot. So this was taken as an average for the whole plot. And then I also created binary variables of whether or not the plots were burned in individual years. I also did a cumulative fire severity. So if a plot burned more than once, I totaled up all of the individual DNVR values. And then I also calculated the total number of burns, which varied between 0, 1, or 2 times. The short-off fire severity is not included in this analysis because it burned outside of the where the plots had been established. I'm sorry, that's to say sunrise, not short-off. I apologize about that. So back to the first objective, which is to identify structural and compositional trends in Linville Gorge wilderness area forests and to overlay those trends with the environmental variables that we have discussed. To do that, I needed to go through the historical data and start by standardizing species codes. We had some variation in the codes that were used. For example, for chestnut oak, we had some variation in the way that the species codes were spelled. So I went through and cleaned all of the data starting from 1992 up until our study. I removed plots from analysis that did not have overstory, so only plots that had overstory species were included. And that eliminated most of the rock outcrop plots. And then finally, I removed rare species. If there was a species that occurred on 5 or fewer of the plots, I removed that species from the analysis. And this is just meant to control for noise in the data so that we get a more standardized answer. And this, after I did this, left me with 66 live species and 105 live dead combinations. And that simply means that I included not only the individuals that were measured as being alive at the time of sampling, but also the individuals that were reported as being dead during the time of sampling. After the data was cleaned, I did some calculations to obtain importance values for each of the species on each of the plots. And importance values they can mean several different things, but how I calculated mine was by using the relative basal area and relative density that were obtained from the count data. So using some very basic math, I obtained basal area from each of the species instances on the plots, and I relativized that by the plot total basal area to control for particularly abundant species, so species that just occurred in very great numbers or particularly large individuals. And I did the same thing for relative density. So that was the one that controls for having many individuals. And then after I had my relative basal area and relative density, I summed those two values to get an importance value for each species, and that on each plot. And that left me with a value that ranged from 0 to 200, with 200 being most important and 0 being no importance. And I will say it was a decision to use the importance values because of the amount of variability in the Linville Gorge vegetation communities, and it's been observed that you have particularly high occurrences of, say, Acer rubrum red maple or types of rhododendron occur in very high numbers, or you have very large individuals of chestnut oak or other species that grow to be very large. And so to eliminate the influence of that data that could be argued as noise, I use the importance values. And that, while it does eliminate some of the noise in the data and the biases in the data, it does prevent us from making any kind of assumptions later of whether the changes that we observe with fire are due to changes in basal area or density. So that's something that's been lost in this data. And then finally, after I calculated the importance values, I performed several statistical tests on the data. The first one being non-metric multidimensional scaling. And this, if you're not familiar, is a statistical technique that is designed to take data that has a lot of variation, lots of different things that are affecting how vegetation is distributed across the landscape, for example, and it compresses that variation into just the major sources. So it's really useful for figuring out and helping to explain how data sets vary. And then principal components analysis is a supplementary statistical technique that helps to force the most of the variation in the data, the majority of the variation in the data, to be held on the first ordination axis, which is something I'll explain in the next slide. And then once I had done those two techniques, I was able to calculate weighted averages for the species, which is simply how they're correlated with the different ordination axes, and then I also correlated environmental variables with the ordination axes. So I'll go through the results and the discussion about the different statistical techniques that I did. So to start, if you haven't seen one of these before, this is an ordination plot. And what you're looking at in the gray are the individual plots with having all of the information for all of the species that have occurred on those plots. And here I have the instances from 1992 to 2014. So there are some resampled plots in here. NMS Axis 1 is supposed to contain the majority of the variation in the data. It's supposed to explain what is causing differences in plant communities across Linville Gorge, most of it. And then NMS Axis 2 is supposed to contain the second most information about variation in the data. What just popped up on the screen is, in blue, the environmental variables that are most correlated with NMS Axis 1, as well as the species that are most correlated or load most heavily on NMS Axis 1. So these are the environmental variables responsible for most of the variation in the species data that we've collected. And as far as environmental variables go, slope position as well as slope were most correlated with that axis, meaning that vegetation communities in Linville Gorge are distributed heavily based on slope of the ridges in the gorge. And that makes sense based on previous studies that have been done. And then interestingly, we see that total fire severity, so when you add up all of the fire severity variables and you get a final number, is most correlated with NMS Axis 1. So it's showing us that fire is the major driver of variation in vegetation data in Linville Gorge. The species that are most correlated are Allegheny serviceberry and pitch pine, as well as American beech and pignut hickory. And we see Amelanchier laevis loading most heavily on the slope position end of the axis, as well as pitch pine, and we know from field work that these species depend heavily on specific slope, on being in a specific place on a slope. Pitch pine, for example, needs to be on ridges. And we see that American beech and pignut hickory load heavily on the end that contains more information about fire severity, and we don't see, especially American beech, in areas where there are high severity fires, and so it has an opposite relationship with that end of the axis. And then what has been added next is the variables that are most correlated with NMS Axis 2, as well as the species that are most correlated with NMS Axis 2. And I think what's interesting here is that we see elevation is playing a major role in the distribution of individual species, as well as the total number of burns, so if it burns 0, 1, or 2 times, if an individual plot did. And the interesting species we see here, I think, is Paulownia tomentosas, which is the princess tree, the invasive plant that there's growing concern is dominating a lot of the ridges in Linville Gorge Wilderness area, and we see it being heavily correlated with an increasing number of burns. While we see Betula allegheniensis and Ilex montana being correlated with elevation, we see these as being, especially Ilex montana, higher elevation trees. What's been added now is the information for acid cove and slope forests. So you see the points have been colored. These are the individual plot points are colored by the year that they were sampled. So this dark red is 1992. The purple is 2014. And the blue lines right now are connecting plots that have been remeasured throughout the years but have burned 0 times. And if you look carefully, you don't really see any kind of pattern in the data. We're seeing a random movement of the individual plots within the ordination space. But if we add the plots that have burned once throughout the sample period, we see much more variation in the data. And we also see, if you notice, it's generally moving from the darker color to the lighter colors, the more recent sample years. So we see a downward trajectory and sometimes even a leftward trajectory with the plot sample points. And if we remember the variables that were correlated with the axes, it was the total number of burns with NMS Axis 2 and the total fire severity with NMS Axis 1. So we are seeing shifts in plant community composition with increasing number of burns and increasing fire severity. And then twice burn, we see even longer, we call these change vectors, the longer distances within the ordination plot, meaning that these plots are even more different throughout time, and it follows the same general trend of responding and changing with fire severity and total number of burns. Does that make sense? If I can ask, does anybody have any questions about that? Okay, I'll move on. So to just rehash and wrap up that section of the research, there were other very similar change patterns observed in the different community types. The two that I was able to really get clear results from were xeric evergreen forests and the montane oak forests. And those had enough samples so that I was able to track changes throughout time. For other community types, we didn't quite have enough samples to be able to do that. But we did see similar responses along the fire severity and fire incidence gradient. We also saw, if I can refer back to this, that the individual plots are widely distributed in the ordination space. And if anybody's walked through Linville Gorge or done field work there, they know that the vegetation is compositionally very different and diverse. And so that's what's been captured in that ordination space. And as I said a bunch of times, fire is a major source of variation in the data. And interestingly, I wasn't able to observe any correlations between the environmental variables, so slope or slope position, elevation, any of that, with the fire severity data that I collected. And I attribute this to two different things happening. One of those is that the Landsat data has a 30-meter resolution, and often what was observed in the field was highly idiosyncratic fire behavior. So we would see very patchy burns in a generally low severity area. We would see patches of high severity that weren't playing out at a 30-meter scale. So definitely the resolution of the data is an issue. And then the other issue could potentially be the time when the images were collected. So some of because of cloud cover, I had to collect the Landsat images in the fire severity calculations a year prior to when the fire had burned, rather than just a month or two before the fire had burned. And so that definitely will have played out in the correlations. And then moving on to my second objective, which is to evaluate whether wildfires have been meeting stakeholders' restoration goals in Linville Gorge Wilderness area. And to start with that, I will first talk through the species that we'd selected as being specifically of interest in this study. So something that when I was starting, I had talked through with the Wilderness Society was the concern that ericaceous shrubs are gaining importance in Linville Gorge outside of their typical range. So typically they occur, in lowland areas where it's wet, and they've been observed encroaching into higher, more upland areas. And so something that was of interest is to see if fire is helping to knock back the encroachment of some of these ericaceous species. And as you can see from this photo, these can grow in very dense thickets and block out desirable understory species from emerging, such as oaks. And so it would be advantageous, theoretically, to the gorge's ecosystem if we were able to knock back the importance of ericaceous shrubs. And the species that were included are listed over here. I included Kalmia latifolia, several rhododendron species, as well as vaccinium species. The second set of species that was of interest was fire intolerant as well as fire dependent species. And fire intolerant individuals have the same argument as the ericaceous shrubs that we have, especially red maple and white pine growing in very dense thickets, and they're blocking out more desirable oaks and more desirable pines from having the sunlight that they need to grow. And so we were curious to see if the fires that have occurred over time had decreased their importance, rather than what's been reported in the field is that their importance has been increasing. And secondly, if fire-dependent species have seen any kind of increases with the various fire instances. And these species that we selected were Pinus pungens, Pinus frigida, so those are table mountain pine and pitch pine, white pine, scarlet oak, oh, I'm sorry, not white pine, white oak, scarlet oak, and then chestnut oak. as well as red oak. And the final species that we were interested in addressing was Paulownia tomentosa, or princess tree. It's an incredibly fast-growing invasive species that definitely is becoming a problem, has been observed to become a problem in Linville Gorge because of its habitat dominance, particularly on rock outcrops where several fragile ecosystems exist. And I have the Wild South logo here. They're doing a bunch of work to help limit the amount of Paulownia tomentosa that's in the gorge. And there's been, last I heard, several research studies that were being done last summer to study further the effects of these invasive species. But we wanted to get at whether or not they're occurring on the plots and if they have any relationship with fire. To do that, I did some very simple math, and I isolated the burn histories that the individual plots, that characterize the individual plots. And what I was left with were several categories, and one was that the plots had never been burned. And you'll see in 2014 that we had none of these plots, and that was because we were focused on those that had been reburned in the Table Rock fire. And then we have also once burned in 2000, 2007, or 2013, and then twice burned either in 2000 or 2007, and then in 2000 to 2013. We didn't have any plots that were burned twice from 2007 to 2013, as those being their only two fires. And the final thing I did was to perform paired t-tests to compare importance values for these species that were isolated from the data before the fires to their importance after the fires, and see if we can detect any significant differences with fire. So the first, as I mentioned, we were curious to see if fire is decreasing the importance of ericaceous shrubs in Linville Gorge, and this is a picture that I took after the Table Mountain fire, that we can see definitely a large amount of dead rhododendron maximums. We're curious if this is a significant difference after fire. And what just popped up on the screen is the instances of unburned plots throughout time, so through the different sampling periods. And we see that through the different sampling periods, we have no significant differences in mean amount of ericaceous shrubs on the plots. With once burned plots that burned in the 2013 fire, we see a significant difference, a significant decrease in the amount of ericaceous shrubs on those plots. And we also see a significant decrease from the unburned in 1992 to 2003, and then a significant difference, and that's a once burned plot, and a significant difference between once burned and twice burned plots. So the twice burned plots have a significantly fewer ericaceous shrubs than do the once burned or twice or zero burned. The next thing that I observed was no significant increases in the importance of fire-dependent overstory species. So we didn't see any increases in their abundance with the different fire events. We did observe some increases in the importance of fire-intolerant species, and that's been observed in the field, but was confirmed with this data that fire seems to be, rather than discouraging the growth of these fire-intolerant species, it seems to be encouraging it. And then finally, and I do attribute this result to the relatively small sample size of the princess tree that had occurred on the plots, but it didn't increase in importance with any but the 2000 and 2007 twice burned plots. And I think that when we were out in 2014, there hadn't been enough time potentially to see the increases in the princess tree, but as I said, it's been reported to have heavy growth, especially along the Table Rock fire area. So to just quickly talk through some of the different takeaways of those results. We did meet a restoration goal of decreasing the importance of ericaceous shrubs. However, I think that we need to continue observing and continue documenting whether or not that difference holds. through time if fire was to curtail or if fire was to increase. And we also would want to see if the absence of ericaceous shrubs did see an increase in the amount of fire-dependent species. Potentially more time needs to pass to see increases in the fire-dependent species. And then we probably didn't see fire being widely distributed enough or severe enough to decrease the importance of fire-intolerant species. That could be another contributing factor. And similar to the monitoring of fire-dependent species, we should definitely continue monitoring for invasive species. Some of the limitations of this study include inconsistencies in vegetation identification, and this just comes with several different field crews having their hands in the same pot, so to speak. So we definitely saw some inconsistencies year to year if we took our historical data with us, with how trees were identified or individuals were identified. And yeah, so that should be considered when thinking about the implications of this study. And as I mentioned, the direct interpretation of importance values is impossible. So with those results that I just mentioned, I can't specifically say whether or not the decrease in importance of ericaceous shrubs was because of a decrease in basal area with very large individuals or just a decrease in overall density of the rhododendron individual, and similar to the fire-intolerant species. We had relatively low sample sizes in 2003 and 2014, and that was because of time constraints and many other factors. But it would be great to continue seeing fieldwork being done to expand the sample sizes after the fires. And then some other considerations include the use of geospatial rather than field data to capture the environmental variables. I think it would have been ideal to incorporate more site-specific instances of the various like elevation and those sorts of variables, but given the time constraints of my study, I had to use the geospatial variables. And then finally, we had the relatively low resolution of the fire severity data, so it would be great to see a higher resolution analysis of the Gorge's fire severity being done. And to conclude, definitely early, so I would appreciate questions if you have them. We see that Linville Gorge's vegetation communities are highly heterogeneous, and that fires have been a major source of variation and change in those communities throughout the various burn instances. We have some meeting of restoration goals, but not all of the restoration goals, and as I mentioned, it does seem that we need to continue monitoring to make sure that if we are burning or introducing prescribed fire into Linville Gorge, that if these are our stated restoration goals, that we are meeting those restoration goals. And additionally, we could, if we were to pursue a prescribed fire regime, to establish certain areas that would be monitored year to year so that we can continue to document these findings. And these are some acknowledgments. I would love to thank my advisor at Duke and the team at the Wilderness Society, as well as Wild South, and my field assistant, Tina Kazang, who's in the picture here, helping lumber down into a plot that was the bottom of the slope, as well as many others. And I did want to mention, in case it would be useful for anyone on the call, that while I was doing this research, I developed a tool that maps fire severity if you have Landsat images to input. And it calculates DNVR and then also draws a polygon you can see in the blue around the fire perimeter. And I'd be happy to distribute that tool if it would be of any assistance to anybody on the call. And with that, I would love to take your questions.
Cassie, this is Hugh. Really enjoyed your presentation. Could you talk a little bit about what the utility of these permanent sites might be long-term? Do you think they could be of use long-term, or, you know, since they've been in a while, is, you know, their utility kind of played out? Or could you talk a bit about that?
Sure, and hi, Hugh. It's great to talk to you. Hugh was my supervisor at the Wilderness Society when I was doing this research. So I think that the value of having permanently established plots cannot at all be undersold. It is incredibly useful to have long-term data so that we can look at these trends over time. And since our goals are long-term, that we want to see long-term health in Linville Gorge, and we want to see long-term resurgence of the fire-dependent species, that to have a record throughout time and that we're able to document these changes consistently is incredibly valuable. And so it would be wonderful to see research teams back out after these fire instances or even without the fire instances to see how things are progressing in these vegetation plots. This is a very rich data set, and it's very exciting to have been a part of using it and contributing to it.
Thanks. That's really helpful.
Oh, sure.
I get another kind of follow-up question that you know I've thought about a bit and wonder about your thoughts on it. As you know, we put, and you especially, put a lot of thought into, you know, the design of the experiment, you know, how the design of the field work, how we would kind of take advantage of, you know, the prior field work best. Looking back on it, is there anything you think would have, that we've been served by doing it differently?
Oh, that's an interesting question.
Designing the field work.
I think that the biggest challenge for our team specifically was finding the plots. And we often would go out. Claire did a wonderful job of making paper maps and documenting pretty accurately where she put the plots in Linville Gorge Wilderness area. But I think it was still quite a challenge each day to locate the plots. As you can imagine, tromping through the forest looking for little pieces of metal that have been burned that are sticking out of the ground. It's quite challenging. And so I think something that I would do differently if I knew going into it would be making sure that I knew or had very solid GPS coordinates and a solid GPS unit to be able to locate them quickly. And I think that would really expedite things. And I think additionally that having, there were 2 of us working on this project, so I think, I mean, more people the better. And so those have been my 2 major suggestions about the study.
Thanks. That makes a lot of sense.
Hi, Cassie. This is Liz Kaylees from the Nature Conservancy. Can you hear me?
Yes, I can.
Okay. I just have a quick little technical question. Just if you could remind me how it works with an NMS. You know, I was really interested in the 2 graphs you showed to try to understand how the different environmental variables, the relative importance they had in explaining the differences in species composition. Is there another, maybe it's in your thesis, methodologically, how do you rank those variables? Like, how can we understand across that list of variables which ones contributed most versus least? Is that something that we can get out of your paper?
Yes. You mean this visual? Oh, yeah.
In addition to the visual, you know, I saw it in the graph, but how do you quantify that, just in terms of methodology? How do you quantify that so you can actually rank the variables against each other and understand which ones contributed the most versus the least? How does that work?
Sure. So the output of an NMS is they're vectors of variation that capture variation in the data. So it's essentially creating an index that describes where and how the data is varying. And so you can correlate your environmental variables with a simple correlation test against those vectors. And that's how I got the elevation is varying with, it is responsible for, second most amount of the variation in the Linville Gorge vegetation data, and the total number of burns is in the opposite direction. Does that make sense? So it's a simple correlation test with the vectors that capture the variation in the vegetation data.
Okay, I think it's coming back to me. So like with a PCA, for every variable, it had a different correlation values, so you would be able to rank them sort of accordingly.
Exactly.
Within an axis.
Yes.
Within an axis.
Exactly,
okay.
yes. And
okay,
I have
so
this,
when you
if it would be useful for you, I have the code. The R code is where I did this in the R statistical software that I did all of this with. So if that would be helpful, I'd be happy to share it.
Sure. I mean, I'm more just curious because you showed, you know, like slope, position, and total severity, but did the other ones, were the other ones just not important at all? And were you just showing us the top two? Or, like, I'm just trying to understand the relative, because you looked at it like 10 different variables, right? So where did the other 8 kind of fall out, I guess is my question.
Sure. The other 8, I can actually pull up, if you just give me 1 second, can pull up where they fell out.
Too in the weeds. I'm just curious.
So the other 8 were not unimportant. I was just showing the 2 that were most important in the directions of their variations. But I can show you which direction. Okay. Okay. Can you see my screen?
Still seeing a graph. Is that what you want? Oh, here it is. Yes. Got it. Oh, good. This is exactly what I was wondering about. Perfect.
Yeah.
And you can interpret the different values as the higher numbers have more explanatory power, right? So
exactly.
I guess I'm trying to understand. So go ahead. I'm sorry.
Oh, no.
I'm just trying to understand, like, you know, with fire, and it was just kind of hard to tell with the arrows. So fire severity actually contributed less than slope and slope position. You know, I'm trying to get a sense of, was fire the most important variable, or did fire actually come second or third down the list after vegetation, you know, just basic characteristics of the environment like slope? And it looks like they're pretty close.
So right. So from the results you can see here, it was pretty much neck and neck. So the slope position where the slope was along the ridge had a positive correlation of 0.14, and the fire severity variable that I calculated was negative 0.142, and then total cumulative fire severity had a 0.09 correlation. So these 2 variables, and then another that if it burned in 2013 or not. So these fire severity variables are less important, if you want to read the correlation that way, than the basic environmental variables in explaining the variation in the data. With the second axis, it doesn't appear to be that way, and that was something that I was surprised about, that you have the fire variables coming out as being more important in explaining variation in the data than some of the basic environmental variables. And I will say that there was accompanying data collected with some of the field instances. Like in 1992, collected slope and aspect specifically at the sites, but given the time constraints of my study, I didn't have a way of quantifying. I didn't have time to quantify the variables that she had collected that were site-specific. So I think that if I had been able to incorporate those, and that's something I would like to do moving forward, that we would probably see differences here. I'm thinking that this might be just a limitation in the environmental data that I collected rather than the case in the field. But that would be something that I'd have to report back on after I'd done the statistics.
Great. No, thanks. This is awesome. Thank you.
Oh, yeah. Does that make sense?
You answered my question perfectly. Thanks.
Oh, great. No problem.
Hey, this is Lisa Jennings on the Grandfather. Can you hear me?
Yes. Hi, Lisa. How are you?
Hey, I'm good. How are you?
I'm doing well. Thanks.
Good. Really interesting stuff here. Really appreciate the work. This is great stuff. I love especially seeing that reduction in the ericaceous shrubs come out so strongly in your results there. One of the things that kind of surprised me was that increase in the fire-intolerant species. And I was wondering, you know, just based on being out there in the field and looking at these plots, were you seeing regeneration of these species, or do you think that the increase was maybe related to their ability to have those multiple sprouts after fire? Could you speak a little bit more about what you saw for those species?
Sure, I would be happy to. And this is something that I saw as a definite drawback to using the importance values, was that we lost the ability to explain whether it was density or basal area, that, you know, if it was big individuals growing bigger, or if it was just a lot of resprouting, and I think a lot of what we saw, especially with red maple, was very vigorous resprouting along the stump line of the trees. And we did see some resprouting of the white pine, and we also tested for sourwood. And again, I mean, sourwood does resprout with fire. So we did see a lot of that. And then I think that the fires were severe enough, what we observed were they were severe enough to kill some of the smaller individuals, but the larger individuals were able to persist through fire unless the fire was quite severe on the plot. And so I don't think that in the Table Rock area that we were able to see the fire severity that we would need to knock back the larger individuals as well. So it seemed to just encourage the sprouting and rather than discourage the growth of the larger individuals. Does that make sense?
Yeah, that definitely makes sense. So, yeah, very, very interesting results again. And I would be, really interested to see that fire severity modeling tool that you've developed too. I think that could help us a lot here. So, if you could send that around, that'd be great.
Sure thing. And something that something else I wanted to mention and that I neglected to mention was that I mentioned that we saw no significant increases in the fire-dependent overstory species, but we did, in some cases, see declines in the importance of overstory species, and that specifically was after the twice burned 2000 and 2007 fires and the twice burned 2000 and 2013 fires. So I thought that was an interesting result and something that I'm still sort of chewing on, and I don't really have a solid hypothesis on why that was happening, but something that I had talked to you about was potentially if there had been regrowth after one of the earlier fires that we're seeing along the ridges, the fire was quite severe, that potentially the severity knocked back some of those fire-dependent species before they had a chance to really establish themselves. That's something that I find interesting and could be a source for further study.
Right. Cassandra, this is Margaret. I would certainly second Lisa's comments. I had two questions. One is the normalized burn severity index. There's been a lot of discussion in the Southeast on using breakpoints that have been established out west and that we need to modify them in the east. So I was curious, did you modify them? And
I did.
You did?
Sorry,
excellent. Right. Well, that was a perfect answer, and getting access to your tool would be fabulous.
Sure.
So if there's a way that we can share that, that would be awesome.
Sure. So the tool actually allows for you to input your own breakpoints. So you can look at your data and decide what you think is an appropriate breakpoint and input that into the tool, and it will draw the polygon based on where you put that breakpoint. But what I did see when I was doing the literature review for this study is that the severity out west is generally much higher than we experience in the east, and so using their breakpoints just didn't seem appropriate, and through the literature wasn't particularly encouraged.
Great. Then the other question was, I mean, I fully understand this was, a one-year sampling, during an internship, but often we see delayed mortality, particularly in larger hardwoods. So, the point that you made on having these permanent plots and being able to go back to them, I think is a really great opportunity. Because, that is, something that we could see as well as, increased mortality from all of the resprouts, from the maples, some of those species. So it's a great foundation to do more work. So.
Oh, yes. I can't say enough about having that established data set and having it to look through time. Has just been enormously helpful as a student trying to learn about these things, but also I think in informing us of how the fires have, or how the gorge has responded over time to these fires.
Right. Thank you. It's been a very impressive MEM study.
Oh, thank you. I appreciate that.
Do we have any other questions? Did anything come up in the chat box, Liz?
Hey, Margit, this is Duke Rankin with the USDA Forest Service. I was curious about the ericaceous shrubs. There was a bit of a list of many different species. I was just curious if there was any attempt to sort of tease those apart to see if some may have had negative responses, others more rich top ones with more positive responses.
Sure. So I did attempt at first I tease them apart in a couple different ways. One of the ways was by a vegetation community type, and unfortunately the sample sizes by the burn history were too small to get any significant information out of them. And that, I think, if the sample sizes had been bigger, would have gone a long way toward helping to tease out specific individuals that were related to one another within these community types. And then secondly, I did an analysis just with Rhododendron maximum and Kalmia latifolia, and I did see the similar behavior where we were looking at, I'm sorry, I'm just flipping over to where we would see decreases with fire events, but again, I was struggling with sample sizes that we don't see Kalmia latifolia and Rhododendron maximum in all of the plots. And once we broke those out by burn history, my power to tell whether there were any significant decreases or increases was essentially just gone. So that was the reason for aggregating across all of these different species, as well as conversations with the Wilderness Society, that we were interested in seeing the behavior across these species and not just specifically, I think, the two main ones that are cause for concern.
Okay, great, thank you.
Does that help?
Yes, it does, thank you.
Mm-hmm.
Cassie, can you talk a little bit about the process of finding the satellite images for the burn units? I know you had some difficulty finding timely satellite images. Could you talk a little bit about that?
Sure, and while I'm talking, I'll pull up I have a table that shows when the images were obtained. And so what I did was I used USGS's repository for this data and went through, and you can individually download images from the periods before and the periods after fire, and you have to inspect them for clouds and any other errors that would make it difficult to detect accurately changes in the landscape. And so you can see for the Brushy Ridge fire, I was able, which happened, I think, it happened in the summer of 2000. So I was able to get that same year's before image date, but I had difficulty specifically with the Pinnacle and Shored Off fires, finding timely images because cloud cover in the spring in Linville Gorge can be quite dense. And so I had to reach back a little bit further than I would have otherwise liked for the Shored Off fire to be able to quantify changes in the landscape. Does that make sense?
Very helpful. Yeah, it does.
Do we have any questions that came up in the chat box, Liz?
No, people have been speaking up.
All right. Well, the numbers of questions seem to have quieted down. One more chance.
Okay.
Anybody? I've discovered that I had tried to break in earlier, and I noticed if you go to the top line, there is an opportunity that you can unmute yourself. So there may have been some questions out there, and people couldn't get through.
One question I have, Margit, is are the presentations available afterwards? I know one or two people that wanted to make this but weren't able to. Are they able to access them later?
I'll punt that question to Liz.
Yeah, we can. This recording will be available, and I'll put a link on the Southern Blue Ridge page on Conservation Gateway and send it to Margaret as well to share around. And Cassandra, if you're willing to share your slides as well, we could post those.
Oh, absolutely. No problem at all with that. I'll I have to make a quick change to an error, but I would be happy to share them.
Okay, very good.
Yeah, that would be great to have that available.
Great. And be sure that we include contact information for you, so if anybody would like to take you up on the offer to use your fire severity mapper tool, that would be great.
Sure thing.
Thank you so much. Any last questions?
Thanks, everyone. I really appreciate it.